To add vectors in 2 dimensions, there are 2 methods that can be followed for the addition of vectors. First is the geometric or graphical method, while the second is the algebraic or analytical method. In this session, we put emphasis on the geometric method. However, the correlation between the geometric and the algebraic method will be shown later on. The geometric method can be classified into 2 methods. The first is called the triangle method. This method is applied when the added vectors meet head to tail or tail to head. In this diagram, vectors A and B are head to tail vectors and form 2 sides of a triangle, while their sum, which is drawn from the tail of the vector A, the first vector, and ends up at the head of vector B, the second vector. This represents the 3rd sides of the triangle. From here, the name triangle method comes from. However, for the second method, the parallelogram method, this method can be applied when the added vectors meet tail to tail or head to head. Here, the 2 vectors A and B meet tail to tail, and there they form 2 sides of parallelogram. So to find the sum or the resultant in this method, the parallelogram must be completed, and then its diagonal can be drawn from the corner of the tails of the vectors up to the opposite corner of the parallelogram, and this diagonal represents the sum or resultants of the 2 vectors called C. An example on the triangle method will be demonstrated and followed by another example on the parallelogram method. In both examples, 2 vectors are given A and B and will be used for the addition of vectors in both methods. We'll make the first choice that these 2 vectors A and B will meet head to tail to apply the triangle method. And then our second choice will be the 2 vectors meet tail to tail in order to apply the parallelogram method. The first choice, A and B, are head to tail vectors. In this example, vector A has a magnitude of 8 units and directed towards the east, and while vector B has a magnitude of 5 units and makes an angle of 60 degrees with respect to the direction of vector A. Use the triangle method to determine geometrically part A, the magnitude of the sum R, part B, the direction of the sum R with respect to that of vector A, or with respect to the positive x-axis. To add vectors geometrically, whether in triangle method or parallelogram method, the student should have a ruler and protractor for this purpose. The ruler is used to measure the length of the vector, while the protractor it will be used for the direction or the angle of a vector. Here we're going to put solving strategy to carry out the addition of vectors. In this method, we have 2 vectors, A with 8 units and directed due east, and B with a magnitude of 5 units and makes an angle 60 degrees with respect to the direction of A. So this is the first step to be done. The student should write down the information related to the vectors before drawing them. And the second notice is the students should take care of the units while drawing the vectors. So each unit given in the problem should correspond to a centimeter on the ruler. For example, if the vector is force where its unit is the newtons, in this case each newton corresponds to 1 centimeter. And here 8 units in the problem correspond to 8 centimeter for vector A, while 5 units for vector B corresponds to 5 centimeters. Now, to add head-to-tail vectors, we'll start with the first vector by using the ruler and put the ruler along the x-axis in order to draw the 8 centimeter length of a vector. And here we are, and the vector A is there. The next step in our solving strategy is to draw the second vector. First of all, we need to assign an angle for the vector of 60. We should make a tick for this angle. Make sure that the length of the 5 centimeter line will pass through this tick. And then draw the line of 5 centimeters for vector B from the head of vector B passing through the tick. And here we are. We have a vector B with an angle of 60 degrees is drawn. The third step in our strategy is to draw the resultant, which starts from the tail of the first vector and ends up at the head of the vector B. Use the ruler to draw this line, and here the vector R resultant is drawn, and the length of this vector is 11.35 units, which represent the magnitude of the sum. To find the angle of the sum, use the protractor again, make a sign for this angle, and then this angle turns out to be 22.4 degrees. And here we are. The reading of protractor gives the direction of R, which is 22.4 degrees. As an application to the parallelogram method, this example will use the two vectors used before, but will be drawn tail to tail, having an angle of 60 between them. The magnitude of the sum of the two vectors R and its direction will be determined. The same techniques used in the previous triangle method will be used here. Now the first step is to draw the vector A by using the ruler again, and then make a tick at the start of the vector and another tick at the end, just to specify 8 centimeter length that correspond to 8 units of the vector A, and then you can draw the vector A, which has a magnitude of 8 units and directed towards the positive x-axis. The second step in the parallelogram method is to draw the vector B, and first of all we use the protractor as before to specify the angle of 60, and then we'll draw a line from the tail of the first vector by using the ruler with 5 centimeter length. Now The two vectors A and B are drawn tail to tail with an angle of 60 degrees between them. Actually, these two vectors form the two sides of the parallelogram. The third step in the parallelogram method is to complete the shape of the parallelogram. To do that, we need to draw two lines, one parallel to the line A and starts at the head of B, and the other parallel to the vector B and starts at the head of vector A. Now, to start with the vector B, we need to specify the angle of the image vector parallel to B, like this. And then next, we use the ruler to draw the 5 centimeter line. Now, we'll have an image vector to B with the same angle. Then next, we'll draw the vector parallel to that of A by drawing a line like this. Now, in such case, the final step is to draw the vector for the sum of the two vectors, and this line that represents the sum of the two vectors must start at this point where the two vectors meet and end up at this point. So this will start from this corner of the parallelogram and end up to the other end of the parallelogram. By using a ruler, the vector is like this. And in such case, the length of this vector will represent the magnitude, which has 11.35 units. To draw the direction, the angle of the resultant vector that represents the direction, we use the protractor and then we assign an angle for it like this, and this angle turns out to be 22.4, which represents the direction of the sum. Here it must be noted that both the parallelogram method and the triangle method for the same vectors A and B will give the same results, with a magnitude of 11.35 and a direction of the sum or result of 22.4 with respect to the x-axis. To understand what does the commutative law mean, we're going to work out the two ways of adding vectors, head to tail in the triangle method, and see how does the commutative law work in here. If we decide to add the vector A to the vector B in here, so A plus B will give us the result C. Will give us result C. Alternatively, if we draw a line parallel to B in here, And this line is an image vector to the vector B in the blue, this dashed line. And likewise, if we draw a line parallel to the vector A as an image vector, then in this case, we can add the vector B, which is its head, end up with the tail with vector A, and this will give us the same result, C. So in this case, this means in the triangle method, whether you start with A, then B, or you start with B and then A, you will get the same result. Similarly, in the parallelogram method, if we add the vector A to the vector B in here, which they have common origin and meet at their tails, then the resultant is going to be C. So A plus B, in this case, equals C in the parallelogram method. Alternatively, if we decided to draw the image line B parallel to the original B vector, and the other image vector A for the vector A in here, and then these two vectors meet at their heads, they are head to head. So in such case, if we add B plus A in the parallelogram method, this will give us the vector again C. So again here, if we add A plus B, we will get the same result as B plus A. This means that the addition of A plus B commute with the addition of B plus A, which means it is the same. The associative law for adding vectors works for more than two vectors in order to obtain the sum or resultant R of those vectors. For example, if you have the vectors A, B, and C, which are head-to-tail vectors, and we decide to find geometrically the sum or the resultant of those vectors, we obviously know that we can do that easily by just drawing the vector R from the beginning of the first vector A, from the tail of the vector A, and then we draw a line to the head of the last vector C, and then you get the resultant. But the question here, we want to use the triangle method in order to add those vectors successively. How can we do that? So the resultant of the three vectors can be added by starting to add the two vectors A and B using the triangle method. Here, the addition of these two vectors will give the vector D. So next, we will add this vector D to the vector C, and the final result will be the sum or the resultant vector R. What we have done here, what actually has been done, is we grouped these two vectors A and B and we add them together, and their result is added in a later stage to the vector C, and the result of this addition of vectors is R. An alternative way of adding those vectors A, B, and C is to start adding the vector B to the vector C to get the vector E when the triangle method is used. Now, the resultant vector of B and C, E, can be added to A, such that A plus E will give us the final answer, the sum R. Now again, what we have done here is we start grouping the two vectors B and C and add them together at first, and the result of this addition of vectors is added in a later stage to A to get the final answer R. And this is all about the associative law, which shows that whatever the way of grouping the vectors and adding them, the final result is the same. Next, two animations will be demonstrating both the addition of head-to-tail vectors using the triangle method and the addition of tail-to-tail vectors using the parallelogram method.
We'll use these animated vector arrows to show a method of vector addition called head-to-tail addition. If we want to add vector B to vector A, we simply move B so that its tail is in the same position as the head of A, keeping it parallel to its original orientation at all times. The sum of the two vectors is found by drawing a third vector from the tail of A to the head of B. This is how the sum of the two vectors changes if vector B is rotated to different orientations. Since the two vectors are equal in magnitude, their sum can have a magnitude ranging from 0 to twice that of A and B.
We'll use these animated vector arrows to demonstrate the parallelogram method of adding vectors. The vectors are positioned with their tails together, and a parallelogram is formed by putting in lines that are parallel to and equal in length to each of the vectors. The sum of the two vectors is the vector formed by drawing a line from the tails across to the opposite corner of the parallelogram. As the angle between the vectors changes, the magnitude of their sum changes from 0 to twice the magnitude of either vector. Here is the same sequence repeated with vectors of unequal length.